Welcome to our exhibit at this year's World Expo. Here's why trains are the innovation that moves everything. It all began in Britain on February 21st, 1804, when an engine was invented that could carry 10 tons of iron and 70 men nearly 10 miles at a speed of 5 miles per hour. Trevithick focused on improving Watt's low-pressure steam engine, utilizing high-pressure steam to make the engines more efficient. His prototype, the Penny Darren locomotive, could reach speeds up to 5 miles an hour. It was in this prototype where the boiler made its first appearance, an invention vital to the success of the high-pressure engine. High-pressure steam produced in the boiler powered a piston to move the train, and the exhaust steam was then turned up the chimney, creating the cloud of smoke we associate with steam locomotives today. In Baltimore in 1827, the Tom Thumb, designed by Peter Cooper, represented the first railroad charter, and it was only 13 miles long. America's first steam locomotive was imported from England in 1830. The east and west coast of America was linked with railway networks on May 10, 1866, by joining together the Union Pacific and Central Pacific Railroads. Less than a century later, trains flourished in the United States under the supervision of industrialists such as J.P. Morgan and became the dominant mode of transportation. Connecting east to west, the railroad had business and commercial implications at its onset. Railroads began to switch to steel, which were stronger and had a longer lifespan than iron. Even the introduction of the electric locomotive began to take place, headed by the Baltimore and Ohio Railroad. With over 200,000 miles of track laid by 1910, the train was experiencing its golden age. Known as the Iron Horse, the industry died down after the monopolistic practices of tycoons inaugurated several new federal laws to reel in the industry. But the main cause of the decline was the rise of other modes of transportation, including cars and planes. The diesel locomotive brought an end to the age of steam engines.
That brings us to today. 40% of today's cargo is transported by a train, and General Electric and Electromotive Diesel are the largest manufacturers of trains today. We reverted to train technology because of the Staggers Rail Act of 1980, and that deregulated the American railroad industry and loosened regulatory restrictions on railroads, giving them greater independence. First, let's talk about the types of engines that trains use today. Trains predominantly use diesel and electric motors. However, more countries are making advancements in maglev technology. Diesel engines work by compressing a fuel-air mixture, thereby generating heat. The heat causes the fuel to ignite and explode in a controlled explosion. This explosion creates the energy needed for driving the vehicle forward. Trains are coming to rely on electric motors due to their advantages in noise, pollution, size, and maintenance. Unlike diesel engines, electric motors don't need a continuous supply of a fossil fuel like coal to keep running. By this system, the larger the train and the longer the journey, the heavier engine you're carrying. On the other hand, modern electric motors don't require tons of coal. Using electricity, they cut everything from pollution to costs. One way they reduce cost is through a regenerative braking system, which cuts down on power consumption. Essentially, the motors become generators during braking and burn off the train's kinetic energy, turning it back into electricity and returning that to the supply. If another train is accelerating nearby, it will use the power generated by the braking train instead of pulling current from its grid. The last type of train technology we're exploring currently is maglev, officially the superconducting magnetically levitated vehicle. These trains use magnetic power to levitate and have three main components: large electrical power source, metal coils along the track, and large guidance magnets on the underside of the train. They currently operate in Japan and Germany, and because the trains levitate using strong magnets instead of a coal-supplied engine or a completely electric motor, they can reach higher speeds and even work when there isn't a readily available energy supply. Japan is home to the fastest maglev train, and it can travel at a whopping 268 miles per hour. In electromagnetic suspension systems, magnets repel. The longest train journey in the world is 10,560 miles long and connects Portugal and Vietnam, and the longest direct rail route in the world is the Trans-Siberian Railway at a whopping 5,778 miles.
Now to the future. With computing power doubling every 2 years, the future opens up so many possibilities for new inventions. There are two major trains that I'm going to discuss today. The first is the hydrogen train, which is emission-free. Their only byproduct is water. The vehicle burns hydrogen in an internal combustion engine or a fuel cell to convert chemical energy to mechanical energy. The machinery is currently being tested in Germany and China. The second type of train is the hyperloop. This train is particularly plausible because it drastically reduces the friction in the air ahead and ground beneath, allowing it to travel at unprecedented speeds. It is projected to travel speeds of up to 800 miles per hour in the future. Because the hyperloop mechanism relies on a vacuum, it also requires significantly less energy than activating giant magnets or electric powered trains of the present. Small pods are aligned along a track of an unwound electromagnetic motor, and when a current is fed through the track, the pods move forward at such a fast speed that it lifts off and hovers above ground. Devised as an ecosystem, Hyperloop technology would include sources of renewable energy and requires less energy than maglev or electric motors. Solar, wind, and geothermal energy will be sources along the tracks and within the tubes themselves. The target is to generate more energy within the ecosystem than the Hyperloop will consume. Faster transportation and revolutionary technology open up more opportunities to people in the future. Things such as lower commute time and more job openings contribute to a larger workforce able to travel further distances for work. Train systems will become the focus of infrastructural improvements and societal use because of its advancements in passenger and cargo transportation. Instead of using cars and planes to go long distances, people will rely on trains more and more to go places and transport things. Trains are the future of high-speed transportation that will revolutionize how we view safe travel.